Concepts closely related to single points of failure are correlated and accumulated faults. Correlated faults happen if there are multiple fault containment regions that have some reason that makes them likely to fail together. Some of these reasons include the following. You could have common design faults, such as the same defective software running in multiple fault containment regions. Well, when that software defect hits, all the FCRs will fail together. You could have common manufacturing faults, such as improperly designed or out-of-spec components. You could have shared infrastructure, such as a shared power supply or a shared clock signal. You can also have physical coupling. For example, you could have two supposedly redundant wires that run through the same wiring harness and are subject to the same failures, such as a loose connector or the two wires shorting together with each other. Or you could have a shared location that gets thermally overloaded or for other reasons causes a correlated failure. The point with correlated faults is that they really are basically single points of failure because there's some single event or single cause that can cause multiple supposed fault containment regions to fail together. The point is that correlated faults are really single points of failure, and that's because there's some phenomenon that can cause multiple fault containment regions to fail together, meaning they're not independent. There's also the notion of accumulated faults. Accumulated faults happen when an FCR has a fault that is either not detected or not repaired. The problem here is that if your reliability math assumes you have multiple redundant fault containment regions, you're also assuming that they're actually working. If they're not working, you have a false sense of security. As a very simple example, consider that commercial airliners have 2 engines or more. The safety case is basically, if you have 2 engines when you take off, even if one dies, you have a second one that you can use to land. But that reasoning doesn't work if on the previous flight one of the 2 engines failed and you didn't fix it before the next takeoff. It is essential to detect and repair faults in a timely manner and to take into account the possibility that you have faulty units during a mission when you do your redundancy calculations.